So good morning. Welcome to the class today. Today we are going to discuss about latching. But before that, I want us to finish up on the last part of the class that we left out last time, and that was the last type of the logic function, and that is the exclusive OR. We discussed a number of logic functions, the not, the nor, the and so on. Today, I want us to talk about the exclusive or it's also abbreviated as the XOR. So, with the exclusive OR, that is the exclusive OR gate. So, for this type of gate, we're just going to pick up from where we left that for this type of gate, that is the exclusive OR, is that it only gives an output when either or it gives an output when either of the inputs is on. That is on. We said it is signified by the use of represented by 1. So when only one of the inputs is on, that is the only time we're going to have an output. That means that when both if you have two inputs, like for the case of this table that is here, that is the truth table that you can see in your screen. For such case, like we can see the first scenario, we have both the inputs A and B, they are off. Therefore, for this type of logic gate, the exclusive OR, the output will be 0 because we have said the only time we have an output is when either one of the inputs is on. So for the second case, we only have input B on. You can see here. Therefore, we are going to experience an output. For the second case, only one input is on, that is A, and therefore we're going to have an output. And for for the last case, both inputs are on, and therefore that means that we are not going to have any output because you have said the only time we have outputs for the exclusive OR gate is only when either of the inputs is on. So therefore, for the last case, both the inputs A and B, they are on, and therefore you're not going to have any output. So such a gate is called the exclusive or the XOR gate. So X represents the exclusive, then the OR gate. We saw what an OR gate is. We said an OR gate gives an output when any of the inputs is on. So if you have 3 inputs and one of them is on, you'll have an output. And for the exclusive OR, the only difference is that one of the inputs must be on exclusively. Just one of them should be on for there to be an output. So there are various ways of obtaining such a gate, that is the exclusive OR gate. And this is achieved by using a NOT gate, an AND gate, and also an OR gate. You can see in this figure 5.16 that for us to have such an output, we are going to have two inputs, A and B. Then you're going to follow them and see the process that they go through for there to be an exclusive or type of output. And you can see that the gates that are there, we have the NOT gate, the AND gate, and the OR gate. So going for, let's say, for example, the input A. Input A is taken through the NOT gate. We say the NOT gate is also called the inverse gate. So the A gate is inverse. Then it is taken through the AND gate. We said for AND gate, the only time we have an output for the AND gate is when both of the inputs are activated. So We have our A input taken through the NOT input, that is the inverse, then taken through the AND gate, and therefore the last step is through the OR gate. So you can draw that. The same case happens. It can also be taken from the A input. It can be taken directly through the AND gate and then to the OR gate, and you'll have an exclusive OR output. For the B output, the same process repeats itself. So one of the ways to have an exclusive OR output is by taking it through a NOT, the NOT gate, and then that is the inverse, and then the AND gate and also the OR gate. You can draw that, and then we can proceed to the next step. So I want to believe that you have drawn that. Um, you can proceed and look at some more explanation. And by the figure 5.17 of the XOR gate, it shows this is a ladder diagram, as we've seen how we draw a ladder diagram. And it is a ladder diagram from the XOR, that is the exclusive OR gate system. So for this one, when there is when the input A, going by this ladder diagram, so when input A and input B are not activated, there is zero output. You can see that when both the input A and B are not activated, the output is zero. But when just one of the input is activated, then the upper branch results will be, the output will be one. So therefore, that means that when you'll have just one of the inputs activated, there must be an output in your ladder diagram. The same case that when just input B is activated, then the lower branch results, this one. When you just have the only input B activated, then you'll have an output in this ladder diagram. But when both the inputs A and B are activated, there will be no output, as you have seen in the truth table. And this is an example of an exclusive OR gate ladder diagram. And in this example of this logic gate, input A and input B have two sets of contacts in their circuits, and one set is normally open. You can see it here for the case of the first the first horizontal line, normally open, and the other one is normally closed. So with the PLC programming, each input may have as many sets of contacts as necessary, depending on the number of inputs that you want to have in your logic or ladder diagram. There are often situations when it is necessary to hold an output energized even when the input ceases. A simple example of such input is a motor. This is when you're talking about the latching. We are done now with the uh, exclusive or logic function. So talking of the latching, we are saying there is often a situation whereby you need to hold and you need to activate to have an input activated, then that input is it ceases to be on. And you're saying a good example of this situation is a motor, whereby you activate this motor by pressing a push button switch. So you press the push button switch. That means that you close the circuit, and then once you release that button, the circuit is open. But that does not mean that once you release the circuit, you release the button that the motor stops running. So that this is a good example of what we call latching in PLC. And going by the explanation here is that a simple example of a latching situation is a motor, which is started by pressing a push button switch. Though the switch contact does not remain closed, the motor is required to continue running until a stop push button is pressed. And the tap latching circuit is used for such a circuit for such a circuit that is used to carry out such an operation. It is a self-maintaining circuit in that after being energized, it maintains the state until another input is received. I don't know if you have understood what you mean by that, but what you're trying to say is that for such an example, that is the motor. It is started by pressing a push button, and although once you release that push button, although the contacts don't remain, but the motor, it is expected to continue running. It is required that that motor continue to run until you push again a stop button. That is, you press as a stop button switch, and then that is when you have that motor stopping. Such a scenario is called latching, Latching. That such a scenario is called latching, and it is used to stay the motor running until the push button is pressed again. Circuits that are characteristic given the previous condition are often needed in the logic control. And in this series, the output is latched by using the output contact itself. So even though the input has changed, that is the input, that means that it has opened. The output condition is fixed. I repeat again, in such a situation that is the in latching, such a situation that is the latching in logic control, the output is latched by using the output contact itself, so that even though the input has changed, that is for the case of a motor, that is the switch button has been released. That means that the contacts are now open, or the circuit is now open. Uh, the output condition, and going for with an example here, that is the input condition is that the motor is now running. It remains fixed until the switch button is pressed again. When there is an exit, another set of contacts associated with the exit is closed, and these contacts form an OR logic gate, such that this or logic gate system with the input contacts, and therefore even though, like, if you have an input A is opened, the circuit will keep the output energized, being assuming that our input A is the push button switch that you're talking about. So even though that input A is open, the circuit will keep the output energized. And going with the example of energized, we mean from that example, that is the motor will continue running. And the only way to release the output is to activate the normally closed contact, that is the B button, that is the B input. So when you activate that, the normally closed button, then that is the only way that you'll have your input disenergized, or you release your input. And you can see here the latch circuit. So you have the input A, and then the input A is normally open circuit, or normally open contact. And then we have the input B, which is normally closed. And then we have the output. We said this is how you represent an output in a ladder diagram. So in this example, that is figure 5.18, when the input A closed, there is an output. However, when there is an output, another set of contacts associated with this output closes. These contacts form an OR logic gate system with the input contacts. And therefore, even if input A opens, as you can see in this large circuit, so even if input A opens, the circuit will will still maintain the output energized. And the only way to disenergize the output or to release this output is by operating the normally closed contact, that is the input B. So to activate it, you just to disenergize the circuit, you activate the normally closed contact. And for going with the latched circuit example here, that is the input B. So you can draw that latched circuit and give that explanation as far as as far as the latching is concerned with this latched circuit. So we are going to look at another example of a latched circuit, and that is the figure 5.19. And you're told that it shows a ladder diagram with the Mitsubishi notation for the addresses. You can see this is the ladder diagram. We have the two inputs, that is the start and stop button, and then we have the motor output. So as far as this figure is concerned, that is 5.19, the motor on off with also the signal lamps, you can see them there. So this latched circuit, it gives a safer operation than the programming of this kind of latch diagram. So we're going to look at, you can draw this, then we look at the explanation. first draw this latch circuit, then we are going to go through the explanation in detail so that you get to understand how exactly this latch circuit operates. So draw this, then we look at the explanation. So I want to believe that you have drawn that. Then we can look at the explanation. So we have those inputs. They are marked X400, that is for the start. Then we have the X41 for the stop. Then we have the motor output Y430. So this is the explanation here. For the X41, that is the input there. That is the first input in this ladder diagram. The X41, the stop button. It is closed when the program is started, and therefore, when X400 is momentarily closed, the Y430, this is the motor output here, the first output. Um, the Y430 is energized. So we are saying when the first the start button is closed, that is like it is powered on, then you'll have an output at this motor output, that is the Y430. That is what we're saying. The Y430 is energized and its contacts close. And this results in latching, as you have explained what is latching. And also the switching off of Y431, this is the second, that is the lamp for power that is not supplied. So that lamp for power that is not supplied it is switched off. And the switching on of the second output, that is a lamp for power that is applied, that is the Y432, is switched off. So to switch the motor off, that is the switch button X41, that is as you can see here, this is the stop button, that is the X41. It is pressed and therefore it opens. That means that now the circuit is not energized. The Y430 contacts open, and in the top rung and in the third rung. You can see the top rung here, that is the first rung, and the second rung. We said rungs are the horizontal arrangement of the circuit contents. And therefore, Y431 comes on and Y432, it goes off. You can see they are interchanging. So that is basically how latching operates. And you can see this knowledge is very widely used, especially when you go out for your attachments. You're going to see whatever we are doing here. This is basic knowledge as far as PLCs are concerned. I don't know if anybody has any question before we look at the multiple outputs with latching. And latching is widely used with the startup so that the initial switch on of an application becomes latched on. You can see this the ladder diagrams here. That is the figure 5.20, which has several outputs. Going with the first diagram there, we can see that there is just one input and two outputs. And you can see they will be operated simultaneously. We have the output A and the output B. That is the ladder diagram, figure 5.20. And you're told there can be more than one outputs connected to a contact, that is an input. And figure 5.20 shows that a program with two output coils. And when the input contacts close, both the coils give outputs. So these are two outputs or two coils that are operated simultaneously by one contact, by one input. There is also that figure 5.21, whereby we have one input and one input, that is input A, that operates two coils, that is output A and output B. But we also have another input. We also have another input that is input B, that is supposed to control the output, that is the coil B. So for this ladder diagram, the ladder run that is shown in figure 5.21, output A occurs when input A occurs. So when you have an input at contact A, then you have an output at output or coil A. And also the output B only occurs when both output A and when both input A and input B occur. So to explain this more, the input A or the contact B is supposed to control only the coil B, that is the output B. But for the input A, this is supposed to control both the both outputs, and also it acts as the main switch. It acts as the main switch. So therefore, the only time you're going to have an output in coil A is only when you have input A activated. And please note that input B does not interfere with output A. And the only time you're going to have an output at B is when you have is when you have both the inputs, that is input A activated and also input B activated. You can draw those diagrams. So such an arrangement enables a sequence of outputs to be produced, and the sequence being in the sequence with which the contacts are closed. And the figure 5.22 illustrates this with the simple ladder program in Mitsubishi and the Siemens notation. These are just companies. And you can see in this figure, outputs A, B, and C are switched on. Outputs A, B, and C. Here they are, A, B, C. They are switched on as the contacts in the sequence given by the contacts A, that is here, the X400, B, and C are being closed. So until input A is closed, until input A is closed, that is, this is like the major switch, that is the X400. Until it is closed, none of the other outputs will be switched on. And when input A is closed, output A is switched on. And then when input B is closed, you can see when input B is closed, there will be an output at Y431. And also when you have this switch C, that is X402, when X402 is closed, there will be an output at Y432, that is at output C. So these are logic diagrams that represent multiple outputs controlled by various inputs. In an exam, you can be told to draw a ladder diagram that you can be given this information, and you're told to represent it using ladder diagram. So this is how you represent such information. That is various outputs controlled by either one input or various inputs. That is the sequenced output. So next we're going to look at entering programs, but I can give you time. Our class is going to, we have just around 5 minutes to finish the class. So you can draw these ladder diagrams and give those explanations. And I can guarantee you this one will be in the exam. So you better be conversant with the same. In case anybody has any question, you can ask now before we conclude the class. I'm waiting to answer any question from you.
Excuse.
Yes, Guru.
I'm asking,
Mm-hmm.
So when X400 is closed,
That is the input A.
Input A
Mm-hmm.
is closed, and then input C is closed, but input B is open. So there will be no output in YC. In output C.
Output C. Yes. So you have X400, that is input A closed, but input B is open, yeah? That means there will be no output at either B or C, because you can see input B controls both the output B and output C. The only output that will be activated is Y430. That is the output A, because the rest, output B and output C, they rely on the switch B, that is the X401. Is that okay?
Yeah.
Okay.
Both of those diagrams below there, they look like rectangles.
Oh, these ones.
Yes.
These are part of the ladder diagrams. You can see the first one represents the input A, the input B, input C, and the output below there. It is always advised when you draw these ladder diagrams, you can see for every ladder diagram that you have come across, it had these representations. It is advised that you draw the same.
So you must draw them, eh?
Yes, I advise you to get conversant with them. But where the math lies, basically, it is in these the first diagrams here, A and B.
Oh.
Because they are the guiding principle. Any other question? We have 3 minutes before the class closes automatically.
Oh, I can see you are recording, eh?
Yes, the class is being recorded. I'll upload it in the YouTube and give you the link.
Oh.
Yeah.
And I don't know what went wrong because
Mm-hmm.
I did not get the password and the class ID.
Sorry?
I didn't get the class password. This for Zoom, eh?
Mm. How
You
did you
didn't
join?
send my email.
You didn't get the ID and the password?
Yes, it was
And how?
given by my
Given by who?
by Irene.
And how did you join?
Yeah.
How did you
Oh, I
join?
used this.
You used?
He shared to me.
Okay, no problem. However you join, it does not matter. I had shared the details on your portals.
Oh, I don't know why they didn't get.
Okay.
It's all right.
Any other question? So I'm going to share with you a question on your portal. Ensure that you attempt that question and you send it to me. I'll share a question now after the class. Then I'll be waiting to see your attempts. So have a good day. In case you have any question, you can reach me via my WhatsApp or via the school portal. Also enjoy your time.